All right, so that whole overview that I just gave, completely ineffective. Here we go. So the hope today is to get two-word parsers up and running for at least the 2001 command and the 2002 command. We had started doing 2 words at the start of, or at the end of last class. If you're just coming in, this is just so that people who watch this video afterwards know what the video is all about. So the goal is to start using these command words. Anything in the 2000s is a command word. So at the end of last class, we had talked about splitting the command into 2 words and looking at the 2 tokens. So this is, that was a shortcut I took. Inventory is actually a word, I believe. Yep, it's word 220. So we already seen that it's possible to, mic level is low and cutting out. All right, well, let's see what I can do here. That's okay. I can crank the mic up. All right, is that volume any better? Geez, I know I've made it now. I'm going to spend the first 10 minutes of class just trying to adjust my audio settings. Mic is cutting out. Have my rabbits decided to eat my sound cable? Okay, well, let's try this then. Properties. All right, so this is not using this headset. This is using the, it's not the volume, it's glitching.
Where's the big mic?
That's a UMass. Okay, so I'll use that. That's better for my ears anyway. Okay, so that, oh geez, that's toast. Let's go down a little bit. How about that? Can we agree on that volume? Okay. Excellent. All right, so for the 3rd time, goal today, do parsing of 2-word commands. Yeah, that's because I'm not in a recording studio, Ben. It's just going to echo off the walls. Before we get to what we're doing today, a bit of administrivia. I am giving, so the vote came down. Everybody is going to get a letter grade, but you can then request that it be turned into a pass-fail grade. So for me, nothing changes. For you, there's a step you can take if you want a pass-fail grade. And I don't know in what situation that will work for people or how it will enter into things like your assistances or any other things in the future. Nobody does. The whole world is figuring this out as we go. Okay. Any other questions about that? The grades for exam 1 should be going out probably tonight. It looks like all but 1 student has been graded successfully and been given extra partial credit. So Tim should be doing that. You should look. He should be pushing it to your remote repository, so it'll be in the README. So if it doesn't say right at the top, like grade some number of points out of some number of points, it hasn't been pushed yet. But it'll be a push probably by Tim the TA, because he and I both have access to your repositories. Okay, so the goal today is 2-word commands. I think this is where we left off last time. We had just tokenized 2 words worth of input. Anything more than that, we would ignore taking 2 words. So tokenize just looks up for that word. It just finds the word in your vocabulary, which is defined by the data file. And once it finds that, it returns the integer based on that. So the integer is the only thing that matters, because it's much easier to deal with ints than strings. So we reduce it to a single integer, one for the first word called myToken, and one called myToken2. And it's optional So we assume it's 0 because 0 isn't a vocabulary word. It's sort of like a null value. And then we say, all right, if there are more than one thing on the command line, tokenize that word as well. From here, okay, we had done this word right here. This is where we left off, and I told you I did it wrong intentionally just to be a little bit smart. So let's start here. Run this. Here we are, and okay, it starts with you're standing at the end of a road before a small brick building, and if I go east, I'm inside the building, and we've printed out the items. If I say get keys, a couple of things happen. It first is going to take get and turn it into a token, and keys and turn it into a token. And it's going to identify that get, what is this searchy thing? Go away. That get is a word in the 2001 category. So there's the 2001 words. Get is one of them. I could have said capture or steal or catch. Any of those would have worked and given us the same integer, 2001. And furthermore, it's going to turn keys into a number as well. If I try to find keys, I think we're going to find it in 1000. Yes, it's 1001. That's the name of that word, or the token of that word. So this is the code that we wrote. We said, all right, if the word is a word that means get, and my token 2 is an item, something in the 1000s, then we should add that item to the player and remove it from the current room. We have to do a little bit of working around because the item number in my items is actually mod 1000. So the keys or the key, those are item 1. The word is 1001, the word is 1, or the item is 1. So we do the same thing. We add it to the player and remove it from the current room. I suppose you could say, really, that we should remove it from the room before we add it to the player, right? Because otherwise it would actually be referenced in two places. The room would be pointing to it and the player would be pointing to it. So we'll remove it from one, then add it to the other. Either way, the end result is the same. It says, got the thing, then it prints the room again, because we're at the start of a new turn, and now there is no keys here. And we've gone ahead and said inven. Inven is the set of keys. That's what's in our inventory. Now that seems to work okay. Does anybody have a problem with the way it's working? Or see a potential pitfall that we might run into? Well, let me try this. We've got we've got the lamp, the food, and the bottle of water. So let's try to get the bird. Oh, it doesn't know that word. Oh, not get. Get the bird. We have gotten the bird. If we inven, I'm not sure why I can't quite type. We have the keys and the bird. Is the bird in the room? Nope. So we should be checking not just that the word exists, but that for this particular word, we have to check that it's in the room that we're at. So we can say player.current_room dot my items contains. And contains is actually looking for an adventure item. So we can get that adventure item. The item is going to be my items sub my token sub2 mod 1000. And since this is getting a little long, I think we can we can do a little bit to simplify this. Int item number equals my tokens of 2 mod 1000. My items sub item number, rather than modding it 4 times. Interesting. Remove item. No, it needs the same thing. And actually, we can go one step further, because every single time I do this, I'm actually referring to my item sub item number. So let's make a reference adventure item temp equals my items sub item number. And let's make temp a little bit of a better item, sure. So we're going to say if my items contains item, remove item, and add item. Except remove item seems to be looking for remove item. Go to definition. Oh, all right, this is a shortcut method that actually looks for the item inside of it. And oh, we were thinking a little bit. Has item. We actually have, that actually makes things a little easier. We had a has item in the current room. So we could have just said has current room dot has item. What? Public. Got to make it public. Has item number. This does about the same thing. And then remove item number. And then add item. It would be nice if it just took a number, but it does not. It has to add the item. Okay. So now let's oh, can't quite see the bottom of it. Let's try this again. Because the test here is, can we get something that isn't where we are? So try to get the keys. Oh, it still says got the thing. Still says we've got the keys. So what did we miss? Oh, we actually have to run the test. If player has item, I just typed it, I didn't actually write it. Well, I must have accidentally deleted a line. I'll have to go back and look at that. So if the player has the item, then remove item, which takes the ID, and then add the item to the player and say got the thing. Okay. Not sure what happened there. Let's try that again. Get keys. Still said got the thing. Player.current room. Well, I'd say that there's a small bug, either in has item, it's part of adventure container, You still have the get the thing in the right line. Yes, but only if it has the item. So if it has the item, we'll remove it from the current room and add it. I think I'm going to have to just do a quick run here, quick debug run. And here we are standing at the end of the road. Get keys. So it tokenizes it. The command list is 2 strings. One is get, one is keys. My token 2 is useless. It's 1001, so that's good. Command is not -1. It is between 2000. It is one of those. Item number is 1. Item is the keys. Then we say if player.currentRoom has item. It's going to look through everything in the items, which there's nothing in the items. There's no items. There's a count of 0, and return false. And it went inside the... It returned false. Why would it... Oh. Because there was stuff at the far end of the line. Well, that was a mistake. All right, I think that was just a typo. Let's try that again. Get keys. Okay. So just so everybody knows, what happened was the if statement applied only to the thing that was already on the end of the line there, or there, I guess. And it was executing unconditionally, whether or not we had the item. So now we've actually dealt with this. And we could even go ahead and say, else, if it doesn't have it, print something like... and the word that we're looking for is command list sub 1. So now when we get the keys, can't find keys. From here, every command is about the same, okay? We have to look at what the command is supposed to do, okay? The 2000s. For example, the 2002 commands are all the opposite. Drop the command. So we can take a look at that. All of these are going to be about the same. We can even take most of this. So we only go in to this loop if it's 2002 and there's an item in there. Okay. And what are we going to do? Almost the same thing, except instead of looking to see if we're in the current room, we're going to be looking not in the current room, but in the player. And because we are inheriting from adventure container, so both the room and the player inherit from adventure container, that's the only change we need to make. And actually, we're just going to take that and say, add that to the current room. Dropped the thing, can't find the thing, done. They were build errors. Did I forget one parenthesis? Else if. So now go east, get the food, and look at the position of the food. Food is third in the list. It's out of the list now. Drop food, and now the food is at the bottom of the list. Could I move? Where would you like me to move it to? Couldn't see anything. To a second screen. Well, if I move it to a second screen, you can't see anything. Oh, I see what was going on. I understand what just happened. I had two command windows open. Okay, let's try this again. All right, you weren't talking about moving this. You were talking about you wanted to be able to see it at all. Okay, so here we are. East. Food is in the third section. Get the food. Okay, it's out of the list. In then, it's in the list. And actually, this is a side effect of the way we've implemented this. ToString doesn't give us, or sorry, when we do inventory, it doesn't do the state of the object. It does the short description. So tasty food is different from, what did it say before? There is food here. There is food here is the state. Tasty food is the short description. So when we're doing an inventory, we're printing the short description. When we're printing out a room, we're doing the state, or the state description. When we drop the food, notice that the food has changed order. It's no longer third in the list. In fact, there's a lot of shuffling that can occur when you do that. Every time you drop something, it appears at the bottom of the list of that room's My Items field. Okay. So questions on get and drop. Give you a second to post that, and I'm going to go on over back to the source code here. No questions? All right. So going over the Fortran for just a second here. This stuff's all, it's well commented. C in Fortran is a comment. What we're looking for is the start of this and the parser itself. All of this is sort of at the beginning of each turn. What happens, the dwarves move and things like that. I want to get to analyze the thing. So at the start of each turn, when you actually do something, starting around 900, line 900, this is where we actually deal with the parsing and each individual item. So depending on what words we're talking about, and it comments them, take, drop, say, open, north, lock, or nothing, those words all go to a particular line number. This is not a Fortran class, but just know that each of these is a line number, and depending on what word you use, you'll go to that particular line number. So when we want to try to find something like get, get killed, get on with it, target assumption. Okay. Each of these sections here, these were the numbers from that previous lookup table. Okay. And let's see. Each of these little snippets, this one snippet, is a particular object word. So here, if you say carry, and you don't give an object, a second word, it says that's okay as long as there's only one item at the location. So this says if there's nothing at the location or one thing at the location, go ahead and deal with it. Otherwise, just assume it's whatever object is at that particular location. So for example, in the game, let me run this here, east x, y, z, z, y. Remember, that's that shortcut. Here, there's only one object, the 3-foot black rusty rod. If I say get, it doesn't actually do anything. It just prints the line again. But in the real game, because there's only one object here, it would actually be okay to say get. It would get the only object that was at the location. There are some special cases that I'm going to let you guys read through. It's up to you to go through this, but here was, so that was get. Here is discard or throw. And as we continue on, we get the next word. So in order, we did get, then drop. 3, or 2003, is say, which is an equally easy thing to implement. You go like this. So, giving you, again, not the full program, but if it's 2003, all we're going to do is say that. And the way that looks in the game so you can see that, right? Say hello. It says hello. Say that right there is something that you may want to do a little bit differently. Okay, it only printed out the second word. Okay. You can make it do sophomoric things. Okay, but on the subject of sophomoric things, let's actually talk about section 6. Because section 6 is arbitrary messages. So there's section 4. Okay. Let's look at section 6 for a moment. Section 6 is interesting messages. You might recognize this from the introduction, the help. Things like information about the dwarves, and so on and so forth. These are special things, even things that'll react to special words. Things like lock and unlock. The text that is required is already there. Since we read in section 6 into a dictionary called My Messages, we can reference these numbers. Okay, so if you're ever looking at the Fortran because you're trying to figure out how a particular section works, let's do light lamp. So here's lamp. Okay, it says R speak 39. 39 is a reference to your lamp is on. R speak 40 is your lamp is off. Where it says R speak 16, it says, hey, it's now pitch dark. If you continue, you will likely fall into a pit. Okay, so a lot of the vocabulary, the words you're going to use, can be found in these little sections. So each one of these is a comment, and then this is fairly straightforward. If the lamp isn't here, and here is a special function that they wrote, but here means on your person or in the room. So if you actually had the lamp and it was just sitting on the floor, you could light the lamp even though you weren't there. Second thing it says is that the property of the lamp or the state of the lamp changes. So I think it's worth it to talk about these two rooms, or these two commands, light lamp and lamp off. So let's build those. Okay, those two commands. Don't care about that one. Oh, that took care of token 2, token 3, 2003. All right, else if the token that we're looking for here, or the word that we're looking for, is light, which is 2007 and 2008. All right. So in order for this to work, light applies only to certain things, in particular the lamp. So we have to check and make sure that the word that we use, the object of this command, myToken2, is equal to the command for the lamp. The lamp is 1002. So if you say light lamp, then we have to do a couple more things. We have to check, is it here? So we're looking for player dot has item 2. All right, it has to have the lamp, or player dot current room dot has item 2. So if you said light and you said lamp, light lamp, and it's here, then we can go ahead and change the lamp. So that's my items sub 2 dot state equals 1. We've changed the state. Almost the same for extinguish. Set the state equal to 0. Now that by itself does the side effects, but there are a few other things that the code wants you to do. So call rspeak39 or rspeak40. It also says if you are in a place that's dark, call rspeak16. So how do we deal with that? Remind me, did we talk about the flags for a room? I don't think I got to that last time. Just in chat, let me know. I'm going to finish doing these two rspeaks. R39 for light lamp. My messages sub 39. My messages sub 40. I'm going to show you why we needed the flags. All right, the reason we need the flags is some rooms in a cave are dark. When you're above ground, there's light outside. But when you are in the cave, a lot of places are dark. That's why you need the lantern to begin with. So we can say if player dot current room dot flags dot has flag room flags dot light console dot write line my messages sub, and I got to look back at what this was, 16. So that's a lot to test all at once, but let's go east. Let's first try turning it on. So where it says there's a shiny brass lamp nearby, light lamp. So it gave us that text, your lamp is now on, and the description has changed. Whereas before it said there is a shiny brass lamp nearby, it says there is a lamp shining nearby. If we get the lamp, we got the thing. We can now, what's a good way to turn off the lamp? I almost never turn off the lamp. 2000. Off. Off lamp. Okay, lamp is now off. But it didn't give us anything about the room. If I, again, use that little cheat XY, ZZY, and I light the lamp, it says the lamp is now on. Off lamp. It says it is now pitch dark. If you proceed, you will likely fall into a pit. The reason it was able to do that is because the room has a property called flags. Okay. So that's the next thing I want to talk about is flags. Flags are a function in section 9. In section 9. Section 9 is a relatively short section. Each one of these corresponds to a bit. Bit 0, bit 2, bit 1, bit 3, 4, up to 9, bit 9. Thereafter follows some number of room numbers. So this is rooms 1 through 10 and rooms 100, 115, 116, 126. Those all have bit 0 set. The bits correspond to the following flags, as described in the comments, section 9. Okay, you aren't going to know what all of these bits mean yet, but bit 0 just means that there's light at that location. Bit 7 means you're lost in the maze. So if you look, these room numbers, 42 through 40 through 51, those are all mazes. It's very difficult to find your way through that maze. Okay, so these flags are set on a room-by-room basis. We've talked about a good way of handling this in class, enumerations. So here's my adventure room. I created an enumeration called room flags. Each one of these corresponding to a power of 2. 2 to the 0, 0 is just nothing. 2 to the 0, 2 to the 1, 2 to the 2, all the way up to 2 to the 9. These are all the bits that we care about. All right. To create a property for this room, I just named it flags of type room flags. This by itself isn't really that useful. It's might as well have just made it an int. I could have just used an integer, a 16-bit integer would have been enough, and I could have done bit shifting and manipulation, but by using an enumeration, first thing I get is the ability to say things like this. Flags equals none, which is pretty nice. The second thing I get, let me actually just show you. Here's where I do a toString for the room, and here's where I do a print for the room. This is all I do to print the flags. I say this dot flags dot toString. Okay, flags is an enumeration, and it's decorated as flags. Flags is a keyword in C# that means each one of these is a bit value, which is what we did. Okay, so there's nothing else as part of this enumeration. But when I run this program, here is a particular room, room 10. And if you look at this room, room 10 is one of the rooms that has light in it. So Here it says you're in the plover room long. It lists all the exits. This was not done by me. Okay, I didn't write the code that changed. Where are we? Oh, I got to go a little higher. Where I say this dot flags dot toString, that automatically creates this. C# figures out that the 2 bits that are set correspond to the field in this enumeration, light and try dark. Okay? So that's a nice thing. The other thing we did in actually getting that, let's shrink this up a little bit. And then get section 9 right here. Here's where I actually read in the flags. So for a particular room's flags, I do have to use bitwise operations. I do an OR equals, that's a bitwise OR, and I take 1 shifted left by the bit number. So 1 shifted left by 8 is 256. 1 shifted left by 9 is 512. And then I cast it. I say interpret this integer as if it was a room flag. And I OR that in. So I say this dot flags OR equal room flag. Once I do that, that's actually built up the underlying integer for that flag. But I can then reference it anywhere. Furthermore, let's go back to our implementation of our commands. So here are our command words. Here's where we extinguish the lamp. So let's take a look at this line. If flags. Flags is the name of the property, but it is an enumeration. Enumerations have the ability, or have the methods built in for has flag. That's one of the things that we have. There's also things like toString and other that we inherit from object, but enumeration specifically has flag, determines whether 1 or more bit fields are set in the current instance. So when I say roomFlags.light, that actually corresponds to the integer 1. Then current room.flags, if you look at room 10 has 2 flags. Right? If room 10 has the try dark flag, which is try dark is flag 8, so that's 256, and the light flag, which is bit 1. So together, flags is really 257. It's bit 8 and bit 0. Or yeah, bit 8 and bit 0. But we can test them individually. So I think that that's a nice thing to do. It certainly makes it more readable. So here we say, all right, if the current room is not lit, then print, hey, you're dark. All right. We can add on to this, because in the real game, let me actually start that up just so that we can play that in a moment. Let's go over and look at the real game. Here we are. If we go east and we get the lamp, by the way, if I say get here, it says I don't understand get because there's more things than just one thing, so get lamp. Then we'll cheat and say x, y, z, z, y. And then we notice it doesn't print the room description until I light the lamp, at which point it says there's a rod there. And when I say get, it says okay. Inventory, I now have the brass lantern and the black rod. Okay, those are all the things that I sort of said were a thing, but haven't actually done yet. Okay. If I off lamp, it says the lamp is now off, and it says, okay, it's now pitch dark, don't proceed. So one of the things that I do in my game loop right now, I want to close this. One of the things I do in my game loop at the start of every time is print the current room. So I only want to do that, though, if there's light. So we can add a little test, because this is a game loop. Every time through is one command. So if player.currentRoom dot flags has the flag light. Oh, well, we actually have to, we can't just say light, we have to say room flags dot light. Okay. Or, so that's one way we could print. If we are in a room that's lit, just print out the room. Or, if the player dot has item, what item? Item 2, the lamp. Or the player dot current location has item, the lamp, and the lamp has to be lit. So that's my items sub 2 dot state equals 1. Now, we have to pay a little bit of attention here. We have to say okay, we want either this, either we're in light or the lamp is here and on. Furthermore, we have to do ors in front of ands because of order of operations. Ands are done first. So we're saying the lamp is lit and either we have it or it's where we currently are. If that's the case, print out where we are. Okay? So nothing has changed here. If I go east, it says we're inside the building, get the lamp. Go into the cave somewhat. Now, it doesn't tell us anything. When we light the lamp, we now get a room description. When we turn off the lamp, it says you're now pitch dark and doesn't print the description. Okay. Believe it or not, we're actually coming up on the point where I don't have to tell you anything else. Okay. There are plenty more commands left to implement. Okay. Things like unlock or open and its opposite, lock. We've done light and extinguish. Wave, shake, and swing, those all mean different things. So for your final project, by the way, only about a third of the class has contacted the TA to get stuck together in groups. Okay, so you need a group. I'm going to put a hard deadline that everybody needs to be in a group by Friday class time, or I stick whoever is left into groups at random. Okay? And if you are a group of 3, you may get stuck with a 4th person. Okay, so these 30 some odd commands are all pretty easily documented. Some of them are a little more interesting than others, but those are the 2000s. The 3000s are a little bit different, okay? Some of the 3000 commands are pretty simple to implement, but sorry, my rabbit is deciding to move about the country here. All right. So any questions on the flags? Flags are just an enumeration. It's just a fancy way of doing bit manipulation that hides all of the secrets and makes it easy to read. Okay. So there's our game loop. I want to go back to dealing with basic movement. All right, basic movement is not a 2,000 word. It's just right here. So the basic words that we use, directional words, command words, here, these words describe exits. And we had a movement table. But movement tables are a little bit more complicated than I let on. There's all this special stuff, okay? Special cases. And we're going to cover at least a few parts of these special cases. I can either... I'm going to take 2 minutes or so to talk about these. A few of the special cases. So I'm actually going to go back to the Adventure Exits class for a moment and just mention a few things. It would be helpful for us to generate some read-only properties that do a lot of the math for us. So the destination is a number. But as we saw in some cases, X, Y, Z, Z, Y, east, south, south, west, south, south, south. Here, there is a grate, and I should be able to go down through the grate. This is my implementation, not the real game. So if I go down, oh no, I'm playing the real game. Let's try this again. X, Y, Z, Z, Y. West, south, south, south. Okay, I'm at the grate, and it's locked. I'm going to try to go down. The whole system gives up because the destination was room 303,009, which is not quite a destination room that exists. Okay, the reason is that 303,009 is really a scripting language. Okay, so when we take this, we're trying to find a number mod 1,000 and divided by 1,000, which means that we really have two numbers, 303 and 9. Now, if you look, 9 happens to be the room right below the grate. Okay? But the larger section is 303. So 303 is the M section. And when we look at that, that says that the property of item 3 must not be 0. The reason it's 3 is because we're looking at M mod 100. Okay? And when we look at what item 3 is, goodness, I forgot how long the movement table is. Okay, item 3. Oh, well, item 3 is also word 1003. It's the grate. So what we're saying here is, in order to go down, the grate must be unlocked. State 0 is locked. So there are these conditional statements. So when we are dealing with movement, okay, as part of these movement things, it's not enough just to say, all right, it contains that place. We also have to check that the destination is a few other things. So since we know the exit E that we're dealing with, we say E dot conditional. That is going to give us, if we look at the adventure exit, gives us what in the documentation is called M. M. So we can easily start implementing pieces of these and throwing exceptions when we don't. Okay, so we can say if E.conditional equals 0, then we move the player. else if E dot conditional, and then we start looking at other places, right? So looks like if it's 100, it's also unconditional for us. E dot conditional equals 100. We can actually just combine that, right? If it's 0 or 100, it's done 100% of the time. Where things get interesting, can't see the code. We can't see that. Oh, because that's open. So let's get rid of that. Okay. Can you shrink the command window? How about we just get rid of the command window, and this is what we've added. We've said, all right, if it's 0, all right. Else if, I want to do at least one more today, and we'll do everything greater than 300. Okay, if it's 300 or more, else if E dot conditional is greater than or equal to 300, all that means is that we're looking for a particular item, and that item number is E dot conditional mod 100. And the state that we need it to be in, and it's the state we're looking for it to not be. So we'll call it forbidden state equals, in this case, E dot conditional divided by 100, which is going to turn 300 into 3, 400 into 4. And specifically 300, if you look at the 300 is M mod 100. Yeah. Property of that particular item must not be 0. So for a 3, I feel like there's a little bit of a problem there, but I think we'll deal with it. -3. I'm just going to say -3. There may be a weird edge case there where things could go wrong, but that's all we're doing. So we found the item and the forbidden state. So if my item's sub item number dot state does not equal the forbidden state, then we can move. And the destination, it's actually a little bit different now because the destination is the full number. But as you look at it, if we're in 300 or anywhere up to that, then we're actually looking at moving to location N, okay, the location that we're used to. So hold on, go right here. And it's not going to be destination, it's going to be E dot, I guess I called it computed destination. Yes, mod 1000. And even that's not quite correct because we really only care if it's less than 300, but that is enough to start testing these things. And I'll say else, for now, throw new not implemented exception, can't handle conditional movements. Okay. And we can augment things from there. I don't think Tim is here. Tim is here. Oh, hi, Tim. All right, so questions. So what I've been doing is augmenting the existing movement code to start sniping away at things that we already knew how to do, like unconditional movement, and replacing it with special cases. It's up to you to go into advent.4f. Probably on Friday, we'll do section 300 to 500. Okay. That will actually be a sort of cute thing. It's actually, I'm sorry, we're going to use 500. Greater than 500, we actually print a snarky message, and then we stay in the same room. Okay. So with that said, we have dealt with section 8, section 9. We haven't really done class messages. Those are only for the end. You know, when you quit the game, it prints out your score. And then there are some hints and some magic messages. But that's most of the data file, and it's a good start on being able to play the game. Everything else is choosing what to add to the program to make it do more things like the actual original game. So you're welcome to go and grab this map and play the game, try things. You can see that with very little, well, relatively little code, we've gotten a map we can kind of move around in. In order to actually test to see if the great code works, we would actually have to write the code that handles unlock. And it's extremely useful to actually look for those sections. They're in the 9,000s, not the line number, but the label number. So here they are. So each one of these is a different thing. Some of them get much more complicated. So for example, the lock command can assume that certain things are there. So lock or unlock, things that you can unlock are things like the door, the cage, the keys, the chain, and also the clam. So each of these is a special thing. So if you were trying to unlock the clam, things get a little weird. The chain is a little bit different, and it involves where the bear is. If you want to know where those things are on the map, there's the bear room. And you can see that the bear is actually tied to the wall with a chain. So why you would want to let the bear out, that's a different problem. Okay, but, and then there's the shell room right over there. So this is a fun little map. It describes things sort of visually and where all the things are. It also includes a sort of chicken scratch way of figuring out through your maze all alike, and is the maze all different? Maze all different. Does anybody see the maze all different? There are two mazes. One of them is the maze of rooms that are all alike, and still at the bottom of the stalactite. Yeah, it comes up to the top. So you have there's two copies of the stalactite. But I don't see the maze of all different. Oh, there it is. It's right above the it'll come to me. Vending machine. All right, that's about it. I haven't seen a few emails. Yes, you should be trying to do this. There's no repo that's going to be assigned to you. Make your own repo, add your own people to it, okay? And part of your deliverable will just be to send me that repo, okay? Any questions on the project? All right. Hold on one second. Oh, she didn't want to be picked up. I wanted to introduce my rabbit, but I guess she didn't want to play. All right, I will see you guys on Friday. Let's put an end to this.